To demonstrate my mastery of the Unit 1 concepts shown here, I will be completing a reaction time lab and working with some motion graphs. The purpose of the reaction time lab is to calculate a person's reaction time. How can we accurately measure reaction time? Using a stopwatch is inaccurate because the operator's reaction time can cause error in the data. So instead, we will design our experiment so that it is repeatable and accurate. To do so, we will place a ruler between the fingers of the subject. As soon as the person being tested sees a ruler falling, they will clamp their fingers together to catch the ruler. How do we measure time with a ruler? It's quite simple. We know that when the ruler is released, it becomes a free-falling object accelerating at negative 9.8 meters per second squared, the acceleration of Earth's gravity. We also know before the ruler is released, it has an initial velocity of 0. When released, our ruler will fall a certain distance per time, every time, according to our equations of motion. By noting the starting and ending positions on the ruler, we are measuring the distance the ruler falls with our subject's reaction time. Now with our initial velocity, v0, known, as well as Earth's acceleration, a, and the measured drop distance, d, we can use the following motion equation to calculate reaction time. Since v0 equals 0 meters per second, we can simplify the equation. Dividing both sides by 4.9 meters per second squared leaves d over 4.9 equals t squared. Taking the square root of each side, we get the square root of our measured distance over 4.9 equal to the reaction time in seconds. Now let's take a look at our experiment procedure and how we will go about getting the best possible data. All we need for this experiment is a ruler and a person. Since we are measuring the distance a ruler falls, how can we ensure the distance we measure is only reaction time? In other words, how do we reduce error? In our experiment, we will have our subject brace their hand against a table so they don't move the vertical position of their arm while they catch the ruler. We will do 5 runs and average the results for the maximum accuracy. With 5 runs complete, I've put the data into a table. In column 4, I've calculated the total drop distance by subtracting the start position from the stop position. Since my ruler was marked in centimeters, I've converted the distance to meters in the 5th column. Applying our formula, time equals the square root of distance over 4.9. In column 6, we can see the subject's reaction times for each of the 5 runs. Averaging the 5 runs, we found the reaction time of 0.19 seconds. From this lab, we can conclude, using the motion equations, we can measure reaction time with a free-falling object. This is because our experiment was repeatable and accurate.